Alright, so on this, you got 4 quantum numbers up here. We're going to go through them one by one and explain to you where they're coming from and how we're getting them. And all the sorts of different little informations about them. So, we're going to go with name, abbreviation, range, and values. Shows, tells us, rules for finding, comes from. First thing you got to get and understand is what these 4 quantum numbers are. It's kind of like a zip code. They come together to make a zip code. Okay, because these 4 quantum numbers give you the location of electrons. So it's kind of like you all inside my classroom right now. If this is the atom, my classroom, and you are the electron.
Except that we're actually in the other room.
So Braxton's sitting in Braxton's seat.
He's actually also in the gymnasium.
Oh yeah. Riley just won't let it go. She's like, oh.
Well, I tried to use it again in my quiz, so now I'm going to bring it up all the time.
That didn't work. So Braxton's sitting in Braxton's seat, and I'm standing here. Is it possible, while Braxton's sitting in his seat, is it possible for me to sit in Braxton's seat?
Yeah, because he's also in the other room.
No.
I mean, we can try.
It's impossible. You are filling that space. There's no way I can fill that space as you're filling that space. If I tried to sit on your desk, I would not be sitting in your desk. I would be sitting on top of you. And trust me, you don't want that. I'm a big boy.
I'm a bigger boy.
I don't know about that.
I do.
Gosh, Braxton.
Okay, yeah.
Are you like videoing this? Is this gonna go?
Yeah. Alright, so in this, it's like zip codes. It's like that. Every one of you hold the position you hold right now. And electrons are the same way. They hold these positions. But in this, everything's based on probability. Okay? You've already been exposed to what orbitals are. And these orbitals are just these probability clouds. And that's what we're focusing on and breaking down. So what you're going to see is the first one is the principal quantum number. Okay, if any of you thought that I said principal quantum hashtag, that also stands for number. So, principal quantum number, the abbreviation for the principal quantum number, so I'll put it in parentheses, is just N. You know how you've seen me draw those Bohr diagrams and put N equals 1, N equals 2, N equals 3? All that, those are the principal quantum numbers. Now, the principal quantum number has a range in values. Now, this is the important thing. N, which is the principal quantum number, can be in a range from 1 to 7. Now, with this number falling within the range of 1 to 7, this is the key. It's always a whole number. Or whole hashtag. Yes.
We gotta figure out this recommendation. You can continue.
Okay.
We'll wait for a proper talk.
Okay, just so you know, I'm recording.
Oh.
You're in the shot.
No, I don't think so.
As he stays in the shot.
Yeah, he is there, right?
Yeah, he came in the shot.
Screen time.
All right. So, it has to be a whole number. It can be 1 or 2. It cannot be 1.5. You have 1 or you have 2. Now, what this shows or tells us is our energy level. Now I can say it. I kept struggling there because I kept wanting to say energy level and I haven't said it yet. So it tells you this is the first energy level, the second energy level, third energy level, fourth energy level, fifth energy level. You know all of those diagrams, those orbitals and all those electron configurations, and we would put, 5s and then we'd put 4d. You're all sitting there like, what's up with the numbers? This is what those numbers are. Those numbers and those electron configurations, that number is the principal quantum number. Alright, so there's rules to finding these. Now here's the fun part. For S and P, let's do this in purple. It's important. So S and P, let's do N equals rho. All right.
Is there a reason that you drew like the?
And sign.
Yeah.
I just didn't want to spell out and.
Okay. Why would you draw that instead of writing out and? Yeah, that is a
I always
inside. Okay, sorry.
I think it looks nice.
Thank you.
I can just never do. I always mess up.
I think Braxton's a sucker.
You know what? You can write
Well,
out
you
the
know,
word
would you
then,
rather-
Chloe.
Hey, Mr. Hall, I think it's butt ugly.
Now you're more correct.
Thanks, Braxton. All right, and then you've seen this before. You already have seen this for D. N equals rho minus 1. Let's see if y'all remember what's F.
Rho minus 2.
Will be N equals rho minus 2. Now when I'm using the word row, what row am I talking from?
What do you
They're all wherever the substance is.
Where the substance is? Off of the periodic table. There we go. Sorry, I was looking for a very simplistic answer. You're spot on. You're absolutely correct. But from the periodic table, it's that row from there, whatever row that element is within. Okay. So that's it for the principal quantum number. You know what the interesting thing is? Why is the principal quantum number ranged 1 to 7? How many rows are on the periodic table? How about that? Man, that's cool, ain't it? All right. How y'all feeling here?
Good.
Make sure I covered everything. We'll hit shells in a minute. Awesome. All right. So going from the principal quantum number, let's go into the angular momentum quantum number. Do you need to look and see what you've done, or would a computer help you with what you're needing to do? Here.
What email was it supposed to go to? Kevin.d.hall.
What's your middle name?
Dwayne.
Dwayne. That's so cool.
Whenever you're ready for it, just ask me. All right, so let's talk about the angular momentum quantum number. So the angular momentum quantum number, this is the one for some reason everybody struggles with. It's these two guys right here that everyone struggles with. The abbreviation for the angular momentum quantum number is a cursive L. Cursive lowercase L, that is. Am I the only person that thinks it kind of looks like a squid?
Well, I'm not gonna say that, so thanks.
It's like the
Principal quantum number?
Principal quantum number is done.
Okay.
It looks like a worm with two big tongues.
There we go.
Okay.
See, now we're getting creative.
Yeah.
How can you not see it?
what'd you say?
All
I
right.
said it looks like a worm with two big tongues.
So there's the abbreviation for it. Now we need to talk about the range of values. What you're going to see is these are based off of the last one that you've seen. Okay, now I know this isn't going to make a lot of sense right now until later on when you see it and we start applying it, but there's only certain numbers can exist together. So in this, what you'll find is L, which is the angular momentum quantum number, will range. Now this is a range. please understand what I'm saying. It is a range of 0 to
Is it like one really big number?
n minus 1.
You should have done the spin one, because that looks easier.
Spin quad number is easiest. Was that a cough? Belch?
What was
It
that?
was like a cough and a hiccup at a baby. Like I went to cough, but then
I like
it came out
it,
a
okay.
hiccup and I got confused.
Okay, so in this, you guys have seen this before. You've seen L. We'll deal with L there. Let's talk about what it shows and tells us. What it does, this is going to be a little different. It describes / tells the subshell.
Shows tails, describes tails, the subshell.
There you go, man.
Well,
The subshell.
never mind.
Okay? Here's the shell. Let's do it in purple so everybody thinks
Is
it's
it a 0 or just regular?
That's a 0. Principal quantum number is the shell. Angular momentum quantum number gives us the subshell.
Okay, so what's the subshell? That might be one question.
No, you're fine. So the subshell is like breaking it down. This will help here. Okay, so shows and tells, describes, tells, the subshell. Okay. This is what it shows. It shows you what shapes you're dealing with. So which one of those you're dealing with. So the subshells, you remember S, P, D, and F? That's what you're dealing with. So this is in terms of L. So angular momentum quantum number, if it's 0, 1, 2, or 3. That's where you're really going to be dealing with 0, 1, 2, or 3. If it's 0, then it's S. If it's 1, then it's P. If it's 2, then it's D. If it's 3, it's F.
This is the rules to find it.
Yeah, these are the rules to find it.
Is that important both in purple or did you just write it in both ones?
Yes. I do not. I don't understand why, but it's
I
like
asked you a
this
this or
right
that
here.
question and you said yes.
Do what?
I said I asked you a this or that question and you said yes.
This is important. Okay, sorry. Listen, I'm not 100% today. Riley, gosh, cut me a break.
I said what? Chloe started laughing because I was so confused.
This right here, everybody struggles with so bad. Please, get this now. If L is 0, then it's an S subshell. If it's 1, it's a P subshell. If it's 2, it's a D subshell. If it's 3, it's an F subshell. So you, yeah, I know. It's hard to say. Like 3 times faster. Okay, so on that, what these subshells are is, you remember when I showed you those orbitals? That's what these are. You remember how many orientations are in a P?
30.
There's 3. There's one on the x-axis, one on the y-axis, one on the z-axis.
What?
The subshell is all 3 of them together. The dashes you
Is the
put.
magnetic going to be
Like each one
separate?
individually?
Oh god.
And then what about the spin
I
quantum?
promise you, don't get flustered by it. It's easier than what you think. But you can see why I like to do these separately on quizzes.
So, okay, just let me try to,
You're good.
so n minus 1, so let's say it was a d, so you would do the row minus 1 and then minus another 1, because to find n for d.
It's different. You're combining different things. So there's like, what you'll see is they're set. I can ask questions like, can this set of numbers exist? So if n is 3, can L be 4?
What?
No. If n is 3, can L be 4?
No.
No.
Because it's 0 to 3
N minus 1.
minus 1.
So it can't. It can't even be the same thing as N. So if N,
So it has to be
even
0 to
okay.
2.
So if N was 7, the highest L could go would be 6.
Okay.
That's
But
but what you're looking at, okay, like, I think this will help you. Okay, look, have you ever, if you look, we really focused on these rows a lot. So like over here, if I'm in the 4th row, then N equals 4, right?
yes.
So what are my possibilities? L can literally be 0 to 3.
Okay.
No, you don't need to turn around. Okay, so in here, there's an S. Can that exist? Yes, because 0, it's an S. Then I have a D. Can D exist? Yes, it falls in that range. Then I have a P. Can P exist? Yes. And then you look and say, well, it goes to 3. Can F exist? Technically, yes, but there's no electrons that go in there. So, like here, breaking it down simpler.
You lost me.
Okay. N equals 2. What's that tell you?
That
N equals 2. We're at the row. So, what can L be?
0 to 2 minus 1/3.
0 to 1. So, what does that mean exist, subshell wise? Within what I'm looking at, I have an S subshell and a P subshell. Do I have a D subshell?
No.
No. In the second energy level, you will never find a D. Look at what you've done. Second row.
Oh, yeah. Oh, okay, so I see now. I was really confused. Wait, can it go past 3?
It can.
What?
But it
Mm,
exists, but we
what?
don't use them. No electrons go in there. These
So it
things can
stops
keep
at
going.
I'm so lost.
Kind of. Like it stops at 3. if nothing will
Yeah,
go
it'll
on.
stop at 3 because of F. That's it.
But it can keep
Yeah, it'll
going.
keep
It'll
going like
just be
4 is G.
But it'll just like keep
Did it go any higher than 7?
It's empty. There's nothing there. Do what?
You can't go any higher than 7 though,
The
right?
principal quantum number cannot go higher than 7. We do not have anything higher than 7.
Can anything in the angular ever go higher than 3?
No and yes. In theory, yes. But what you're going to be looking at is in that theory, it can, but in actuality, it never will. It'll never go past 3. Why? What 4 blocks do you have? S, P, D, F. Is there anything else? No. So in actuality, it never will. What you guys are going to see is we're going to do a couple of these problems with some ranges. And I'm going to ask you, can these 4 quantum numbers exist together? And it's yes or no. And then from there, we're going to break from that, and I'm going to say, give me the 4 quantum numbers for this element. And then once you start with it, you're going to be confused. You're going to feel how you're feeling right now.
A little too late for that.
But then you're going to be like, dude, this is awesome. Yeah, this is great. Everything's great and wonderful. And then I flip it.
And then we're
And I say, here's the 4 quantum numbers. Tell me the element.
Whoa now.
And then you're confused for a little bit. And you're like, booyah, this is awesome. This is the greatest thing ever. We should have started with this at the beginning of the year.
Never gonna
Okay, well, I have a really dumb question. Like, when you say that we're going to have to do with the quantum numbers, is it going to be like a range of numbers, like 4 sets of ranges, or are we going
There's
to actually find
You will actually find.
numbers?
You know how we broke the periodic table down for the field order with the electron configurations? We're going to break the periodic table down again, that same one, but for the quantum numbers. Because what must I give you on a quiz?
Yeah.
So you literally have the key to finding your answers right there.
Okay, so the angular momentum only gives you the row. So you find an element, so the other two are gonna give us the rest of the information to find the element.
Do what?
So we had to find an element, but I only give you the row the element's in. So the other two are gonna give us the
This will
information.
give you the row. This will let you find the row. This tells you the block.
Okay, wait, can you
I'm gonna write that
do this
down.
again?
All right, hold on.
Super confused. Just real quick, just do it again real quick.
This gives you the row. This gives you the block. Which part, Chloe?
Okay, so it says n minus 1.
Yeah.
Okay.
That's for finding ranges.
Okay, so then n minus 1, you said it was 2, so the 2 minus 1 is 1.
Yeah.
Okay, so what do you mean when you drew the little arrows to the S and P? Because I know it says like 0 equals S and 1 equals P. So what if, that's just a, okay, it's just a range. And it has to, never mind, I talked myself through it. I just
Awesome.
I
No
just needed
way.
to ask myself.
I have one now. We haven't like we haven't went over how to find the actual number for either of these yet, right?
We've not went over how to find the actual number.
Okay, I thought I missed.
I want to give you.
That's
I want to give you the 4 numbers. Give you the rules for how to find them, what they mean, and then once you have the 4 numbers, then we'll start cranking and using them.
and figure out how to actually find it.
Yeah. Okay, y'all can ask Colton, okay? Colton had me last year for chemistry. You feel like this on day 1, but then eventually you catch on, you're like, this is kind of cool.
Yeah, it makes sense.
It's
They
just,
all like link to each other. It comes together. It makes sense.
you know how you are all confused and asking all the questions and electron configurations? You were like, okay, that makes no sense. Like, why? Why are you telling me just accept it? Now we're going into this is why. Now you're getting all your answers. That's why I love chemistry. It gives me my answers. Are there any more questions?
No.
Okay, so this is the important thing. Principal quantum number will give you the row and it tells you the shell. Okay, what you're in. Angular momentum quantum number will give you the subshell. It'll tell you the block off the periodic table. Alright? We feeling good?
Yeah.
Yeah.
Awesome.
Sort of. We got it.
We haven't been over like the shell and subshell. It is hard to say. That's like the when we drew the circles, wasn't it? Is that what it is? We drew like.
Are you talking when we
and
did
then
this?
We did the energy labels. Yeah.
Yeah, so here's n equals 1. Here's n equals 2.
Oh, so I remember you doing that.
Yeah. So in this, n equals 1. This is what we're talking about.
Okay.
So what this is, it's kind of like whenever you're trying to find a location of something. Okay, so like Oceana's zip code's 24870. But then I want to say like Matheny is 24860. So 248. They're both for Oceana and Matheny. But then the change is in that next digit, 7 and a 6. Remember, you cannot obtain the same position as something already. Matheny cannot be in Oceana.
Technically, it can because 2 things to get
No. Because when you're looking at everything, you're breaking this all down and say they cannot. This electron can be here, and this electron can be right next to it, but it can never be inside that electron. That can't happen. They're separate. They're 2 different. They can sit next to each other. It's kind of like, 2 guys go to the movie. Okay, if they observe bro code, there's an empty seat between them.
Yes. Yes.
But
Yes.
But, okay, if 2 guys go to the movies and they take 2 girls, let me tell you how this is going to break down. The girls are going to sit next to each other. The guys are going to sit on the outside next to the girls they're dating.
Yes.
Yeah, I have it.
Okay? Now let's say that there's a bunch of friends that go. It's always going to go guy, girl, guy, girl, guy, girl. That's how it always breaks down. That's broken. Okay, they're never going to sit on top of each other, but they'll sit next to each other. Make sense?
Yeah.
Help you out? Okay.
Molly went to the movies and saw like 4 guys go to the movies together, and there was like they took up a whole row because they wouldn't sit beside each other.
Broke up.
Reach over the seat and give it to the
No, this is not the correct
Go ahead.
terminology. But if you added another circle, how many would it be n equals 3?
Yeah.
Not weird.
So this is what we're doing. This tells us which one of these big circles we're in.
Yeah.
But then from that, this tells us what we're looking at inside of that circle. Because, okay, so like in here, in
That
n
little
equals
space
3.
between 2 and 3 is what we're finding. Like
Yeah, like here, it
angular
breaks that down.
momentum.
So 2 and 3. So if we're in the third energy level, then this is what I have in there. I have S, a P, and a D subshell. So then this will break it down to where I get to focus on which one of those. So let's say that L is, I don't know, 2. If it's 2, then we're looking at the D subshell. So S and P we don't care about. We're in the D subshell. Now that D subshell, what's it break down to? 5 orientations. So the next thing you're going to deal with is the magnetic quantum number. So your magnetic quantum number, it's abbreviated M sub cursive L.
Lowercase m or uppercase?
Do what?
Lowercase or uppercase?
Lowercase. It's a lowercase m and it's a sub lowercase L. Now this has a range also. And remember, these ranges are just to state can these numbers exist. It exists from negative L to positive L. So it will go from the negative angular momentum quantum number to the positive number of the angular momentum quantum number, and it's all in whole numbers. I should have said that on both of them. Whole numbers. Same for here.
I have a question.
Yeah.
How can L be negative?
It's the range. You remember how I told you whenever we went through the orientations, and I was explaining that to you, and I showed you P. P was simple. It was X, Y, and Z.
Yeah.
But then when you went to D, I told you it was going to get confusing.
Yes.
Because then this orientation is X, Y minus Y, Z. And this one is X, Y minus Y, Z.
Yeah.
Or I think I just double
Yeah,
said
yeah,
that. I did, my bad. But okay, so it's like this one's XZ minus ZY. Okay, those are really, they're just confusing.
Yeah.
So we use numbers instead.
Okay.
So like for example, okay, we picked D. So D, what's the value for L?
You get 1. If it
D.
1. 2. Oh.
Two.
I'm sorry.
It's okay. So what would be the possible ranges for the magnetic quantum number?
-2 to 2.
-2
Ah.
to 2, which would be -1, 0, 1, and 2. How many numbers did I just put up there?
5.
How many orientations does a D orbital have?
5. Oh.
Oh! What?
Do F.
Your spin quantum doesn't
I'm
have.
not doing it. Okay, so on this.
Hey, I have a question about the SP and D.
Okay.
Like, it's gonna make sense, but my mind's just not there right now. Why did I only go to D?
Here,
Like, yeah,
because N is 3.
but there's,
3
where's that
minus
coming
1
from?
is 2.
It's 2.
SPD. You can't have 3.
0, 1,
Okay,
2.
okay,
F can't exist there.
okay. I see now. I got
You're
it.
good.
And I was like, oh, God.
Think about it. What's the first F that you deal with when you go to that bottom level there? 4F. It's in the 4th energy level. There's no 3F. It's 4F.
Gotcha.
Is there a 2D? Not. N equals 2. 2 minus 1. 1.
Okay.
0
I
and
forgot
1.
I didn't know that's where the -1 came in. Okay.
No, you're good. Okay, so in this, you have that range. Now, what's it tell us? It tells us the orbital it actually tells you the actual orbital you're dealing with. It will also tell you the orientation. So you have the orientation.
play in the video.
It's gonna be funny if it does not pick up the music. Okay, so on this, or we're dealing with orientation. Now with this, it's gonna be a little different, okay? Because you have to remember how I talk. I mentioned to you about Hundrel. I really didn't break it down and make you memorize it, but Hundrel is talking about like the empty bus seat. So every orientation gets one electron before it gets the second one, right? This is still going to apply here. So let's go over here, back to the periodic table. I think I already have a video of breaking this down. I'll have to look. Okay, so like we're dealing with the D. Okay, the D block goes from 3 to 12. So this is how you'll actually see it break down for you. Start going through the orientations with the columns. -2. What comes next? Where does the next electron go? Does it go in the next dash, or does it go in the first dash you put? Next dash. -1, 0, 1, 2. Every one of my dashes have an electron now. So what do? We go back and start again. So -2, -1, 0, 1, 2.
That's where the pairing comes in with the
Ah.
two arrows, right?
Do what?
That's where the pairing with the two arrows comes in.
That's where the pairing with two arrows come in.
What?
That's because you guys haven't really done it yet.
We got it.
So when you're looking at this, rules to finding comes from, I'm just going to say breakdown.
Is there like a class in this, or is it like
Periodic table. PT stands for periodic table. All right, then the last one. I gotta get this last one in really, really fast. Okay, magnetic. The spin quantum number is abbreviated M sub S. M sub S is simple. M sub S. Here's your range: +1/2 or -1/2. What's it show and tell us? Spin of the electron. No,
half or
look.
-1/2? Wait. Half or -1/2?
Yeah, half -1/2. How do you find that or tell? If it points up, it equals +1/2. If it points down, it equals -1/2. I know you're a little confused about
That
this.
is the only thing that's made sense.
We'll work with it tomorrow. I just want to get you the rules, get you the quantum numbers, okay? So take your time. We'll hit this up tomorrow.